Let's do another Excel project. This one is for capital assets pricing model, which is a big hit in the modern financial world. So what you're looking at here are the monthly returns for a stock called Visa. I'm sure you guys have used a Visa card or at least know about it. It's actually a public listed company. You also see Standard & Poor's 500, and this is a market index. We use it to represent the U.S. stock market. You also have the monthly return for Treasury bills, the T-bill, and this is for the risk-free return. And you are required to calculate the expected return, standard deviation, coefficient variation for the stock, the market, and the T-bill. And then you need to conduct the CAPM analysis and show a scatter chart with the monthly return data and then get the beta estimated. Okay, so let's get started. So when you are looking at the monthly returns, the easiest thing to do is to get the expected. So the expected return, just to simply take the average, you just select all the returns in the column and then hit enter. Okay, so you can see on average for Visa stock, each month it generates 1.8%. And if you use 1.8% times 12, so that's going to be 21.5%. So that's a pretty big. All right, and then you can just drag it all the way to the right. All right, so you will see the monthly return for the stock market and the risk-free. And then to get a standard deviation, it is also very easy. Just do STDEV and then select all the returns. Hit enter, and then you just drag it. And the coefficient variation is also a piece of cake. Just use the standard deviation divided by the expected return. All right, and then just drag it. All right, so what you see here is for the stock, the standard deviation over expected return, which gives you the coefficient variation is lower than the market, so that's not bad. So we want the coefficient of a variation to be as low as possible. Premium for the stock and for the market. So I just do a risk premium for Visa and then risk premium for the market. All right, so it's pretty simple. You just use the stock return minus the risk-free return. Okay, and you also do it for the market return minus the risk-free return. Okay, so these are called risk premiums, and these represent the excess return in addition to the risk-free rate. All right, and then you just drag them down all the way right here. So you got all the risk premiums for the individual stock and also for the market. And to get the CAPM model, you can run regression analysis. You can just simply use the slope function. So you can just generate the slope. All right, pretty easy to type, right? So the y values would be the stock risk premium, comma, and the x values would be the market risk premium. Okay, then hit enter. So what you see here is a value of 0.9. All right, so 0.9 basically means for the stock of a Visa company, if the market changed by 1%, then the stock would change by 0.9% at a risk premium level. I'm not saying the raw return will change by 0.9. I'm talking about the risk premium of the Visa stock will change by 0.9% if the market risk premium changed by 1%. So this is a Visa beta. Okay. All right. And then how can you do it in other ways? So you can just simply run a regression. So you will need to insert the regression function here. So you go to options, you go to file, and then options. All right, and then you do add-ins. Okay, and you will see Excel add-ins. Then you make sure the analysis toolpack is in there, solver add-in is in there. Okay, And then the rest will be pretty simple. You go to data, and then you will use the data analysis button, okay? And you will scroll down until you reach regression. The Y values would be the risk premium for Visa, and X value would be the risk premium for the market. Okay, then you hit OK. All right, and then there's a separate spreadsheet generated. So you can see that there's a coefficient for X variable, and this is your market risk premium. Okay, and the coefficient between market risk premium and Visa's risk premium is 0.90. So this is consistent with what we have here, the 0.90 generated from the slope function. Okay, so those are two ways to get the stock data. The third way is to use a scatter chart. So you can just select a blank cell, okay, and then insert. You will see a lot of charts available. Just do scatter chart. I want you to do the first one, first row, first column. And then once this blank chart is generated, I want you guys to do select data and add one series. And this series' name is Visa's beta, or you can just manually type in. The X values would be the risk premium for the market. The Y values would be the risk premium for the stocks. Okay, so after this is done, you will see a lot of data points being plotted in on the chart. Okay, and you can see that generally they follow a trend that when the market risk premium goes up, the stock risk premium also goes up. Okay, so that's a very good chart. And then you can right click on any of the data point, and you will see add trend line. So you just add a trend line, make sure it's linear, and then you can just display equation on chart. Okay, display equation on chart. After you check that, you will see an equation saying y equals to 0.9046x plus a very small number. And this 0.9046, this number is actually your beta. Okay. Oops. Okay, so the 0.9 beta has been generated in 3 different ways, and not only in regression analysis, but also in the slope function and also in this scatter chart analysis.